Hello students, we are going to study rationalizing the denominator today, and for rationalizing the denominator we are going to consider fractions where the denominator is a surd, whether it can be a simple surd or whether it can be a mixed surd. So anyway, in both the cases we are going to study. So for first example we are going to study about a simple surd. For example, say we are taking 1 by root 2. Alright, so here automatically you can see that the denominator is a irrational number, and this irrational number is of a special kind because here it is the square root of a integer which is of a positive integer which is not a perfect square, right? Hence it is a surd, and in surds there are some properties that we have already discussed in the previous class, and hence we are going to use those properties and some properties of fractions also to rationalize this denominator. That is, since it is a surd, we need to make it a rational number, and you know what is a rational number? The denominator should become a rational number. So how do we do that? You know that in fractions, if you multiply the same thing with the numerator and the denominator, right, the fraction remains equal. So we are multiplying root 2. We are using the property that you have studied in class 8. Root 2 into root 2 is equal to 2. So when we are multiplying it, we get root 2 into root 2 as 2, and 1 by 1 into root 2 is root 2. So here now your denominator is a rational number. 2 is a rational number, right? So that is called rationalizing the denominator. Now this is a very simple one. Now what if you have problems more advanced than it? For example, if I ask you to simplify this problem, it's quite simple, the answer is quite simple, but at the first place and the techniques that we have already studied will not be suitable for this problem. For example, here you have the denominator root 2 plus 1. So when you have the denominator root 2 plus 1, so if you take the LCM and then you need to multiply with 3 and then you need to multiply with root 2, that will become too lengthy process, right? So there are other techniques that we are going to follow. So for that you need to know an expression, algebraic expression, and that expression is what? You have a square minus b square equal to a plus b into a minus b. So we just check whether it is in the format of a plus b or a minus b. If it is in the format of a plus b, simply we multiply the numerator and the denominator with a minus b format, and if it is a minus b, we do the reverse way, we multiply a plus b. So for here we shall multiply the numerator and the denominator. Now since we are multiplying the denominator and the denominator contains more than one term, so we give a bracket out here and then we multiply root 2 minus 1, and here root 2 minus 1. We are multiplying the same number root 2 minus 1 and root 2 minus 1 to the numerator and also to the denominator, right? So what we have now that is equal to, then we also have this 3 and minus root 2, right? Let us simplify this entire problem only, not just rationalize the denominator of this term. So next what do we see? You see that the numerator becomes root 2 minus 1 because it is being multiplied with 1 right here, right? And here you have a plus b and a minus b, so it will become a square, a square minus b square, and these things remain same, right? So next you have root 2 minus 1, and here root 2 square is 2 and 1 square is 1. This 2 also remains same until now, right? And then you have root 2 minus 1 divided by 1. Now this 2 minus 1 is equal to 1, so we are not writing this divided by 1 in this case. Okay, we shall just keep it like this only. Root 2 minus 1 only we shall keep it, and then we have plus 3 and then minus root 2. So this plus root 2 and minus root 2 gets cancelled, and you have 3 minus 1, which is equal to 2. So a problem like this, got a simple answer like this, right? And we got that answer by using the property, by using the technique of rationalizing the denominator. Now this is called rationalizing the denominator. So for any other case you can just do it like that only. We will take some other one more example for that. So let us take this, say 2 minus root 3 divided by 2 root 3 minus 3 root 5. Okay, in this case again we need to rationalize the denominator. Your question is to rationalize the denominator. So we have it is in the form of, the denominator is in the form of a minus b, right? So what we do is we multiply a plus b to both the numerator and the denominator. So this is our numerator here, out here, and we multiply a, this is our a, 2 root 3 is our a in this case, and we have 3 root 5 as b. So we multiply a plus b. So we multiply this same thing to the denominator, right? And then 2 root 3 plus 3 root 5. Now see, you can do some multiplications very easily also and directly also. You don't need to put those squares and everything every time. Sometimes you can directly write. You know that ultimately your answer will be a square minus b square. So what is 2 root 3 whole square? 2 root 3 whole square, directly you can write the answer, right? But anyway, we shall, since we are doing it for the first time, we will write it. Okay, 2 root 3 whole square, and this would be 3 root 5 whole square. Always that a square minus b square format only. Sometimes other techniques are also used, alright, but that is more advanced, and we are not going to study that. Sometimes you might have the denominator to be in the format of a square plus ab plus b square, and we might need to multiply a minus b. In that case it will become a cube minus b cube, and sometimes it is solvable that way also, but we are not going to discuss all those things, and that is not necessary for you now. So on the numerator you can see that we need to multiply 2 with 2 root 3 and 2 with 3 root 5 at the first place. So 2 into 2 root 3 is 4 root 3, right? 2 into 2, first we multiply the rational terms and then we multiply the irrational terms. So rational terms are 2 and 2, so we are multiplying that. 2 into 2 is 4, and then irrational term is root 3. Then 2 into 3 root 5, so the 2 into 3 is 6, and that would be root 5. And then we have a minus sign, so 2 into root 3 into root 3, so root 3 into root 3 is what? 3. So 2 into 3, that would become 6, and root 3 plus 3 root 5, so that would become minus 3 root 15. So that's a numerator. Nothing else can be done with the numerator, but in denominator things become more simpler. So we write 4 root 3, the numerator as it is, right? And then we go for the denominator, and we see that what is the denominator. 2 root 3 whole square, that is equal to 2 square and root 3 square, right? We have to square this 2 also, and we have to square this root 3 also. So squaring the 2 is 4, squaring root 3 is 3, so 4 into 3 is 12. So we write here 12, and in this case we have 3 square 9 and root 5 square is 5, so we write 45, 9 into 5. So 12 minus 45 is equal to how much? That is equal to minus 33. So we can write it like this also as a fraction, minus 33, and then we can write like this, 4 root 3 plus 6 root 5. Let me write this irrational part again before. So 3 root 15, and then we have minus 6, right? So that is also rationalizing the denominator. We could have also written it like this, minus 33 here, but this is another style of writing. I wanted to show you also that also. Okay, thank you.